So in this example, we are looking at using our primary trig ratios of sine, cosine, and tangent to solve for unknown sides. And we're doing that actually now in two different triangles. So we're putting it together in application. So what's happening in this question is that we're trying to help some rock climbers find the height of the cliff, which I'll label H in my picture. And it's an inaccessible height. But I do have some other information in my picture. So I know 30 meters along the bank, and I know 69 degrees in that flat triangle that's sitting in the same plane as the water there. So I'm gonna start by just focusing on this nice right triangle here. And I know that I can label across from the 90 degrees the hypotenuse. I'm given 69 degrees as my angle. And so I'm gonna label opposite across from that 69 degrees and my adjacent here. So I have the adjacent, which is great, and I'm looking for the opposite because I want to know this shared side that's also in my other triangle. Which ratio uses adjacent and opposite? That would be our tan ratio. So tan of the angle that's given is equal to the opposite, which we don't know. I'll call that x. That's the length of RB over A, which is 30 meters. And then to find x, the next step would be to multiply both sides by 30. So 30 times tan 69 will give us the answer for x. And I know to multiply by 30 because that's the opposite of dividing by 30. So I'm getting x is approximately 78.15 meters in my picture. So I can now go into this diagram and relabel this side 78.15 meters. And now I'm going to draw my attention to this vertical triangle here that's sitting along, I guess it's in the vertical plane, it's perpendicular to the water there. And we are looking for the H, and we now have this side here. So we are going to be looking at the tan ratio again because my hypotenuse is always across from the 90. Across from the 43 degrees that we're given would be the opposite, and the adjacent would be here. And we want to know about the hypotenuse, and we're given the adjacent. So that would be our tan ratio again. So we're going to be looking at tan of 43 degrees this time, and it equals H over 78.15 meters. And again, to isolate H, you're going to multiply both sides by 78.15 to get rid of dividing by 78.15. We do the opposite. So 78.15 approximately times tan 43 should give me a value for H of approximately 72.9, and I'm just going to round that to one decimal place. So 72.9 meters would be the height of the cliff, and I could make that conclusion.